Hello class, Mr. Cluns here. We are working on the next unit. So welcome to trigonometry. This unit deals with triangles. It has something to do with like Pythagorean theorem, right triangles, things like that. It works more with finding angles though. The Pythagorean theorem dealt with finding sides. This deals with finding angles. And it sounds a little confusing at first, so just kind of bear with me. Then hopefully by the end of the chapter, it starts to make more sense. We are going to start with reviewing degrees. Okay, this spot over here is considered the starting point, 0 degrees. If you go up, that's the positive direction. Down, that's the negative direction. That seems to make sense. And if you go all the way around the circle, back to where you started, that is doing a 360. Some of you may have done a 360 on a snowboard or on ice skates or something like that. If you go halfway around, that is 180 degrees. Okay, if 180 is there, then up here is 90 degrees. Right in the middle would be about 45 degrees, etc., etc. If you're going down, that would be negative 45 degrees. If you go down a little further, that would be negative 90 degrees. Okay, if you're going in the positive direction, all right, so if you're going in the positive direction this way, 180 plus 90 is 270. So 270 is the same location as negative 90, is just depending on which way you went to get there. So those are called coterminal angles. Co means also, or something close to that, and terminal, like a train drives into the terminal and stops. The Terminator stops things, if you've seen the movie. Okay, now let's see what we have to do. Say problem 1. It says draw the angle on a unit circle, then find one positive and one negative angle coterminal with the given angle. Okay, the first problem, that's interesting. There doesn't appear to be a problem. Let's make up one. Negative 225. Problem 1 is negative 225. So where is it and what else stops there? Okay, this is 0. That's the negative direction. So there's negative 90, negative 180. And then a little further, let's see how much would you have to go further. 180, 190, 200, 210, 220. About 45 degrees further would get us there. So that spot is negative 225. So it's 45 degrees further than 180. All right, to find something else that stops there, let's go on the positive one. Okay, so from starting here, going this way, that's positive 90 and 45 more. So 90 plus 45 is 135. So that stops there. Now we have to find another negative angle. Well, isn't the negative angle just negative 225? No, that's the problem. So if we want to find another negative angle, let's see what we could do. How about we just go all the way around? If we do a 360 and then 225 more, we'd have it. So how about doing a 360 and 225 more? Those are both negatives. Okay. So what is 225 plus 360? $585. So that's negative 585 degrees. That was pretty interesting. Okay, let's try one more. How about let's make up a good problem. How about 405, 405 degrees. Let's try to figure out where that is and what else stops there. Okay, this is 0. That's the positive direction. So all the way around is 360. And let's see, how much further do we have to go? So 405 minus 360 is 5, 10, 45 more. So 45 more would be right there. So that spot is 405. So we went 360 and 45 more. Now we've got to figure out what else stops there other than 405. Well, if we start at 0 and go up 45, that would work. What else stops there in the negative direction? Well, let's see. We could go negative 90, negative 180, negative 270, plus 45 more. What's 270 plus 45? That would be 315, and those are both negatives. So 45 degrees and negative 315 degrees stop at the same place as 405. Okay, so that is a quick introduction to how degrees work. So you should pause the video now and do the first few practice problems, and then come back and we'll start this. So good luck on your practice problems, and I'll see you in a few minutes. Okay, here we go. Now, we're going to do some actual trig. So the degrees was just what trigonometry was based on. So here's some actual trigonometry. Okay, let's see. We're going to need some background. All right. The trigonometric functions are, where do I have room to write this? Let's see. The trigonometric functions are sine, abbreviated SIN to save writing, cosine, abbreviated COS to save writing, and tangent, abbreviated TAN to save writing. Okay. Now, the sine, cosine, and tangent are the names of ratios. I don't know why they got that name, but they did. The sine ratio is the opposite side divided by the hypotenuse. The cosine, that ratio is the adjacent divided by the hypotenuse. Tangent is the opposite side divided by the adjacent side. Okay. There is a mnemonic device to help you remember this information. Sine is the opposite over hypotenuse. That's so. Cosine is the adjacent divided by the hypotenuse. That's ca. And tangent is the opposite divided by the adjacent. That's toa. So, ca, toa helps you remember what ratios you have and what they are. So sine, cosine, and tangent are the names of ratios. All right, I don't know why I circled that S. I could be consistent and change my circle to over there. All right, now, the ratios are going to eventually help us find missing sides and missing angles in a triangle. So this is the background that will help us find missing parts. Okay. Now, the 30, 60, 90 triangle. This is one of our favorite triangles. Okay. This is the 60 degrees. This is the 30 degrees. We like the 45, 45, 90 triangle also. This is 45 degrees and this is 45 degrees. Okay. Oh, I forgot to tell you something else. Okay, the opposite, the adjacent, and the hypotenuse. Those are the names of the sides. But here's an explanation for that. Okay. Let's see here. Okay. If we draw a triangle and say this is the angle we are working with. By the way, for some reason in trig, they use a lot of Greek letters. So that's the Greek letter theta. It's kind of like an X, but it stands for an angle. They use Greek letters, whatever. Okay. The side opposite the right angle is called the hypotenuse. And I don't know why. Okay, now we have two other sides. We have the side opposite our angle, and we have the side touching our angle. The side opposite our angle, let's call that the opposite side. And the side touching our angle, well, touching, another word for that is adjacent. Like what states are adjacent to Minnesota? Wisconsin and Iowa. Okay, now, we could have a similar triangle, but say we knew where we were working with that angle. The side opposite the right angle is called the hypotenuse. The side opposite our angle, theta, is called the opposite side. The side touching our angle is called the adjacent side. So some people ask, well, can I remember the adjacent side? That's always the longer side. No, look, the adjacent side switches positions depending on which angle we are working with. The hypotenuse stays the same, and the opposite side and the adjacent side are determined by the angle. Interesting. Okay. Now, here's our 30, 60, 90 triangle. Now, we're going back to this. This side, called the hypotenuse, is length 1. This shorter side is a half, like a half an inch, half a foot, whatever unit you're using. And the longer side of our triangle is the square root of 3 over 2 inches, or feet, or whatever unit we're working with. So we leave off the unit. It depends on the problem. If we're in Europe, we might be using centimeters. In America, we're using inches. Okay, the 45, 45, 90 triangle. This side, called the hypotenuse, has length 1. The other two sides are the same length. They're the square root of 2 over 2 inches. Okay, now you're saying, where did these come from? Okay, trigonometry deals with ratios. Ratios you reduce, okay? So if you have the ratio 2/4, you'd reduce it to a half. Okay, so we're going to work with ratios. The easiest number for the hypotenuse to be is 1. It could have been 4, but then the other sides would have been bigger, and you would have ended up with like 4 over 8 rather than a half. So it's easiest to work with a hypotenuse of 1 because it'll be like already reduced, or at least close to it. Okay. So let's try to figure this out. Cosine is the name of a ratio. Cosine is the ratio, the adjacent side over the hypotenuse. So the ratio will end up to be like 2/3 or something like that. And then we'll use that ratio to find a missing side or angle later. So the cosine is the ratio adjacent to the hypotenuse. So they're saying at 60 degrees, what's the cosine ratio? Well, I don't know, but I can figure it out with a little sketch. The first thing we have to do is find 60 degrees. Well, that's 0. Going up is the positive direction. 60 degrees is about there, give or take a little bit. Okay, that's 60 degrees. Now we draw a triangle toward our x-axis. If we draw it toward our y-axis, we'll screw up our opposite and adjacent. So you always connect it to your x-axis. Now, Notice what triangle we're using. We're using this one. Our side lengths are, hypotenuse is 1. The shorter side is a half. The longer side is the square root of 3 over 2. So we're starting at 0, 0. To get to this point, we're going over a half, up the square root of 3 over 2. That gets us to 60 degrees. So now we have a triangle, and we can find the cosine ratio. So the side adjacent to 60, touching 60, is a half over the hypotenuse. So that's my adjacent side, that's my hypotenuse. So what's a half divided by 1? A half. So at 60 degrees, the cosine ratio is a half. And that'll be very useful for finding missing sides and angles a little bit later. So that was fun. Okay, so that's our answer, a half. Okay, so this is saying at 30 degrees, what's the tangent ratio? Well, I don't know, but I can figure it out with a sketch. Okay, so 0, 30 degrees is about there, give or take a little bit. That's 30 degrees. Now we're going to make it into a triangle by connecting it toward the x-axis. The hypotenuse is 1, always. The side opposite 30. Look over here. The side opposite 30, and look over here. The side opposite 30 is a half. So I'm going to put in that side length. That's a half. And this bottom side, the side adjacent to 30, adjacent to 30, that's right there, is square root of 3 over 2. All right, the tangent ratio. Tangent is the opposite side over the adjacent side. That is the tangent ratio. It's called tangent, and I don't know why. Okay, so the opposite over the adjacent is, okay, opposite, what's opposite of 30? That's a half. And what's touching 30 or adjacent? That's the square root of 3 over 2. Now you might be saying, well, that looks terrible. You're right. It does look terrible. But division is the same as multiplying by the reciprocal. And we can make it look better. We can cross out the 2's and write 1 over the square root of 3. That's the tangent ratio. That's the exact tangent ratio. Like your calculator would tell you some weird decimal. So if like the tangent of 30 on your calculator would be like point something, something, something. But we have an exact value because we like the exact values better in math. It's theoretical. We're not going to build a table. We're using theory. If somebody else wants to build a table, they can use our theory to build it. Okay, let's try this one. Sine of negative 135. This is 0. The negative direction is that way. This is negative 90. And then we have to go 90, 100, 110, 120, 45 more, which is right in the middle. So that's negative 135. Now, we always connect our triangle toward the x-axis. Okay. Now, this angle in the middle, from here to here, that will help us figure out which triangle to use. So from there to there, that's 45 degrees, because this is 180, and that's 135, so that's 45 degrees. Okay, now, 45 degrees, that's this triangle. So our side lengths are square root of 2 over 2, square root of 2 over 2, and our hypotenuse is always 1. Hypotenuse is always 1. The sides are square root of 2 over 2 and the square root of 2 over 2. But now, the square root of 2 over 2 and the square root of 2 over 2, we're going to make these into directions because we have to get down to this spot. We have to get back and down to get to that spot. So this middle spot here is 0, 0. This middle spot is 0, 0. Okay, you're going back, that's negative, and down, that's negative. So they're both negative. So the sine of negative 135 Sine is opposite over hypotenuse. The opposite side is negative square root of 2 over 2, and the hypotenuse is 1. So the answer is negative square root of 2 over 2. We've done. Okay. Let's try the cosine of 225. All right. Let's see. Are we supposed to use the same picture? This is going to get messy. All right, let's try this. I guess we're supposed to. All right. So 225. So this was the answer to problem 3. Now I'm supposed to scrunch in problem 4 somewhere or other. So the cosine of 225. The cosine is the name of the ratio adjacent over hypotenuse. I don't know why they call it the cosine ratio, but they do. We won't worry about it. Okay. 0 going up. This is 90. This is 180. And you have to go 45 more. So that spot is 225. Oh, that's the same as 135. They're the same spot. Those are coterminal angles. Interesting. Okay, now the adjacent side, that's this side. That side is the adjacent side. This side was the opposite side. So the cosine of 225 is the square root of 2 over 2 over 1. It's negative. So my answer is negative square root of 2 over 2. Interesting. Very interesting. Okay, what was I going to say? So remember your positives and negatives. Oh, one thing I was thinking about saying is all of these problems you can do with just 2 triangles. 2 triangles, that's not that hard to work with. Exactly. Once you get the hang of it, it's not that bad because there's only 2 triangles. But it takes a little time to get the hang of it. Let's try 2 more to see if it's coming along nicely. 0, negative direction, negative 45, right there. Connect your triangle to the x-axis. Find your reference angle, this angle here in the middle. That angle's 45. Now you can match it up with the triangle. 45 degrees, that's this triangle. So my side lengths are 1 square root of 2 over 2 and square root of 2 over 2. Now we're going over, that's positive, and down, that's negative. So this side would be negative. And cosine is adjacent over hypotenuse. Now, clearly, the adjacent side is square root of 2 over 2. And the hypotenuse is always 1. So that's our answer. Okay, one more. Tangent of negative 225. 0, negative direction, that's 0 degrees. Negative 90, negative 180, negative 270, too far. 225 is right there. Always draw your triangle toward the x-axis. This angle here would be the reference angle. How far is it from 180 to 225? It's 45 degrees. Well, same triangle. I just about have this memorized. It's 1 square root of 2 over 2 and the square root of 2 over 2. But wait, you're going back, that's negative, and up, that's positive. All right, tangent of negative 225 is opposite over adjacent. Opposite over adjacent. The opposite side is the square root of 2 over 2. The adjacent side is negative square root of 2 over 2. So this is the opposite side. That's this one. And this is the adjacent side. That's that one. Opposite over adjacent. Okay, this looks terrible, but don't worry. You can simplify it. Because division is the same as multiplying by the reciprocal. Those cancel and those cancel. These are all ones. So you're left with 1 over negative 1, which is negative 1. All right, now give these problems a shot and see what you can find. So you're finding ratios, which we'll eventually use to find missing sides. Good luck.